So welcome back, guys. We are through with everything on oxidation and reduction now. So what we want to do now is to solve all of the past questions on oxidation and reduction. If you're here to subscribe to our channel, please subscribe. It won't cost you anything. Just click on that subscribe button to help us to promote this video and for you to also get updates anytime you want to have a useful video for you, one way or the other. So quickly, we want to solve all of the past questions on oxidation and reduction. Now, this past question is called fact success. Fact success. So it's one of the past questions we also use with the students. And now I have questions on oxidation and reduction. So, but how many questions? There are over 85 questions here. So out of the 85 questions, I will solve the first 40 for you, while you will solve the remaining 40. Is that taken? So you're going to solve the remaining 45. So just try to follow through. If you have watched all of the videos we've done on oxidation and reduction, then you should be able to. So these are the notes on oxidation and reduction that we've talked about so far: how to balance redox equation, text for reducing agents, then and redox equation itself, then how to do those calculations and all, then this and this. So let's move on to solving the questions now. So question one says that the oxidation number of chlorine in potassium chlorate is. I say you should note some of these compounds like potassium and potassium chromate. If they say potassium chromate, that's K2Cr2O7. If they say potassium permanganate, that is KMnO4. If they say potassium chlorate, that is KClO3. So just note those ones. So now, because they might not give you the formula directly, so they now say, what is the oxidation state of chlorine in potassium chloride? I taught you how to do this. So let's quickly check that out. So you're going to have KClO3. Now we want to get that of chlorine. So you remember the oxidation state of potassium here is going to be +1, plus, let's say that of chlorine is X. And you remember I told you oxidation state of oxygen in all compounds is -2, except in peroxide and superoxide. So you are going to say 3 into -2 because there are 3 of it. That will be equal to 0, right? So 1 plus X minus 6 is equal to 0. So X is going to be 6 minus 1, and that is going to be +5. So our answer for question 1 is +5. Question 2. Consider the equation A2O Fe2 plus Cl2 2F2 plus 2Cl minus A2O. The only ion which behaves as an oxidizing agent is. I told you the last time that the one we call oxidizing agent is the one that has undergone reduction, while the one we call the reducing agent is the one that has undergone oxidation. So looking at what we have here, which one can be our oxidizing agent? So you will look for the one that has undergone reduction. Is that taken? Now, if you look at this, this is Fe2 plus to Fe2 plus. Actually, that's not possible. There must have been a typo error in the question. But let's look at this one first. This will go from 0. If I start putting, you remember hydrogen here will be +1, oxygen will be -2, this is +2, this will be 0 if you remember. Then this will be let me say +3, not +2. And this is -1, this is +1, this is 0. So water has nothing to do here. So we can even cancel out the water. So we are focusing on these guys. And I told you that anytime they ask you this question, don't pick your answer here. There is no answer here. Automatically now, any of these guys in my options, they're automatically out. So even if I don't know what to do, I will only be left with these two. And so I can guess any one of these two. Those are part of the things you do during exams. So now, from what I have here, the only ion which behaves as an oxidizing agent is what? You can always pause the video to try to answer first before you now continue. So now, looking at what we have here, chlorine will go from 0 to -1. 0 to -1, is that reduction or oxidation? Is it reducing? That means 0, -1, -2. That's reduction, Abby. So that means that this chlorine is the one that is acting as an oxidizing agent. Is that taken? So your answer in this case will be B. Is that clear? So that's the answer for this. Number 3. Let's move on to number 3, which means that this one must have undergone oxidation. it must have gone from +2 to +3. So if it undergoes oxidation, both of them cannot undergo reduction. One will undergo oxidation, one will undergo reduction. So this must have been +2 to +3. So this is a typo. So this is a reducing agent, this is the oxidizing agent. So let's move to number 3. For number 3, the reaction of zinc with copper 2 ions in aqueous solution can be represented as follows: Cu2 plus zinc plus copper plus Zn2 plus. So this is the equation. I think I gave you this equation when I was teaching you. So they are now saying that the reaction of zinc with copper 2 ions in aqueous solution can be represented as follows. So what do you think? A, copper 2 ions being reduced. Is that true? Yes, because you are going from +2 to 0. You remember, +2 to 0, that's reduction, Abby. So it has been reduced. Why zinc is being oxidized? Because it's going from 0 to +2. That means zinc is the one losing electron here. When you lose electron, your oxidation number increases. When you gain electron, your oxidation number reduces. So option B, zinc is being oxidized. That's true. Zinc is being oxidized, going from Zn to Zn2 plus. That's oxidation. Copper 2 ions being reduced. That is also true. So maybe they are trying to tell us which one is not true. So let's move on. Copper 2 ions are being reduced. Copper 2 ions being reduced. Then option C also say copper 2 ions are being reduced. This kind of all these books saying, it's still saying the same thing. Copper 2 ions are being reduced and zinc being oxidized. Now look at what happened in this case. You can see that even if there might be typo or whatever it is, that's why you have to be very careful. Option A is correct. Option B is correct. Option C is even correct. They might wanted to type that is oxidized there, but fine. Option D, look at option D. Option D says copper 2 ions and zinc are oxidized. That is wrong. But now look at E. Copper 2 ions are being reduced and zinc being oxidized. That's the best answer to pick. So you can have correct answer, you can have more correct answer, you can have most correct answers. So you have to be careful. Don't just rush to pick your answers. So the answer here is option E. Copper 2 are being reduced. It goes from +2 to 0. While zinc is being oxidized, it goes from 0 to +2. And in the question, they didn't say which of the following is false. If they say which of the following is false, the best answer to pick would have been option D. So number 4, the oxidation state of manganese in potassium permanganate. So what did I say potassium permanganate is again? That's KMnO4. So that means that you want to calculate for manganese in KMnO4. So now to get for manganese, this will be 1 plus, let's say manganese is X, plus 4 into -2, because oxygen is -2, and for neutral compound everything will be equal to 0. So I can now say that 1 plus x minus 8 is equal to 0. X is going to be 8 minus 1, and that is going to be +7. So the answer is potassium tetraoxomanganate 7. Do you get that? So the answer here is +7 in number 4. Number 5, in the reaction above, I think this one is more like number 1. So you to pick the answer. You can see now that it has been corrected here now. So number 6. In which of the following reactions sulfur dioxide acting as an oxidizing agent? So in a question like this now, you look at it. If they ask that where is it acting as an oxidizing agent, then that means you want to look for where it has undergone reduction. So let's look at option A. Sulfur went from plus 4 here. If you calculate it here, it's +4. Then here, +6. Now I told you that SO2 can act as both reducing and oxidizing agents in the last class. So it has gone from sulfur +4 to +6. So what does that mean? That's oxidation. So in that case, this guy is acting as reducing agent. So option A is wrong. Here, +4 to +6 is still the same thing. +4 to +6 is still the same thing. +4 to 0, -2 to 0. So if you look at this, it's going from +4 SO2 now to 0, because they said sulfur dioxide. So it's going from +4 here to 0 here, and that is what reduction. And in that case, it is acting as an oxidizing agent. It's going from -2 here to 0 here. That's oxidation. So A2S is acting as a reducing agent. SO2 is acting as an oxidizing agent in this reaction. But yeah, from +4 to this is 3 times -2, that's -6, -6 plus 2, that's +4, right? So that means nothing has changed here. So this is not a redox reaction. It is not even a redox reaction. It's left from +4, it is still +4. This one to +1, it is still +1. Oxygen -2, it is still -2. So nothing has changed here. So the best answer is option D. It went from +4 to 0, and that is reduction. So it has undergone reduction here. And when it undergoes reduction, it is known as what? The reducing agent. So number 7. The oxidizing agent. So number 7, which of the following does not happen when a zinc rod is introduced into a solution of copper 2 sulfate? So you put zinc into a solution of copper 2 sulfate. So this is like the equation. So you have zinc rod. Zinc rod is solid. You put it in a solution of copper 2 sulfate. Now, copper 2 sulfate can be written as this: Cu2 plus SO4 2 minus, for simplicity. Now, when this reaction happens, it will give you Zn SO4 plus Cu. So now look at this reaction. What has really happened? This is aqueous. That means that these ones are in solution. This is also aqueous, and this is solid. So now the solid zinc will go from 0. This one will be 0. This will be +2. This did not really change, but this is +6. This is -2. This is +2 here. This is +6. This is -2. That's why I said it didn't change. So why this one is 0? So if you look at what I have here, I'm going from 0 to +2. What has happened to zinc? That's undergone oxidation. Copper has undergone reduction. So let's go to an option. So that's number 7. Which of the following does not happen when it does not happen? So A, electron flows towards the zinc rod. Now look at this place. For zinc to go from zinc Zn to Zn2 plus, Zn to Zn2 plus, what has happened? If sodium, let me give you the one you know. If sodium goes from Na to Na plus, what does that mean? It has lost one electron, Abi. So if zinc should go from Zn to Zn2 plus, what does that mean? It has lost 2 electrons. Do you get that? So it's the same thing. So, and loss of electron is what? Oxidation. So electron is flowing from zinc to copper. If copper goes from Cu2 plus to Cu, what does that mean? It has lost 2 electrons before, but now it has gained it back. So which means it is gaining 2 electrons. So it is undergoing reduction. I gave you an example like this when I was teaching the class. Then it undergoes what? Oxidation. Yeah. Do you understand that? So now, going to that option again. So we have which of the following does not happen when a zinc rod is introduced into. So A, electron flow towards the zinc rod. Actually, electron flows away from the zinc rod. You apply this in electrolysis, and we'll treat electrolysis in our next class. B, the zinc rod dissolves. Yes, the zinc rod was solid, then it dissolves into an aqueous. So it will now form Zn2 plus AN. So that means it has dissolved in solution, but it was solid here. Why the copper that was in solution before becomes solid. So that is true. Option B is true. The zinc rod dissolves. C, the temperature of the solution changes. Yes, during this reaction, temperature changes. It can either be exothermic or endothermic, and the solution of metal should be exothermic. So the blue color of the solution gradually disappears. Now, why? CuSO4, anytime you have copper in solution, the solution is usually blue. Is blue when you have copper in solution, and zinc is usually white. So now copper was the one that was in solution before, which means the solution will appear blue. When you now put zinc, zinc will be displacing copper, taking copper away from the solution. And what does that mean? That means the blue will start disappearing and you will start seeing white. That's what that option, I think option D is saying. Do you understand that? I'm explaining each option because you might see your own question in different formats. So E, copper metal is deposited. Yes, that is true. If you look at this now, what's this one? Copper solid. So it went from the solution, it's now gained electron from zinc, and it's become a solid. So the only option that is not true is option A. I noticed option A is not true from the beginning, but I didn't rush to pick my answer. I had to check through every other options first. But you don't really have much time, so it's something you can do. So option 8, in question 8, the oxidation state of manganese in KMnO4, we just did that. That is plus 7. We did that in question 4. So that's plus 7. Now, number 9, oxidation is the process of what? Gain of electron, loss of electrons. I already told you to remember oil rig. That in oil rig, oxidation is loss of electron, reduction is gain of electron. So, bless you. So the answer is loss of electron, that is oxidation. And let's look at the other options. Gain of electron, that's reduction. Loss of electron, that is oxidation. Gain of hydrogen, that is also reduction. Loss of oxygen, no, that is reduction. Addition of the highly electropositive elements, that is also what? Reduction. So do we understand that? So don't forget that. Let's look at number 10. In number 10, in the reaction, carbon is reacting with nitrate. So you form this. And I say nitric acid is acting as what? Your answer. Funniest thing is that you can see, look at CO2, NO2, NO, A2O. There are a lot of them here, and most of them might even be in the option. But now this is our focus: carbon and 2HNO3. Then I said nitric acid is acting as what here? This is nitric acid. This is carbon. Carbon here is going from 0 to plus 4. Going from 0 to plus 4, that's what? Oxidation. And if this is undergoing oxidation, that means what made it to undergo oxidation must have been this guy. So this guy is called the agent that brought about oxidation of this guy. I'm telling you that so that you don't have to waste time in the exam. We can calculate here and check, but there are several nitrogen. You have to also be wise, be intelligent. If I focus on this, I will first calculate for this, do for this, then try to check through. But ordinarily looking, I can just look at carbon that is the only one. It goes from 0 to plus 4. And I know whatever happens to the opposite of it happens to this. So if this is 0 and this is plus 4, that is oxidation. That means this one is the reducing agent. I told you the one that undergoes oxidation is the reducing agent, while the one that undergoes reduction is the oxidizing agent. And if this one is automatically undergoing oxidation, this one is undergoing reduction. And that means that this one will be the yes, this one will be the oxidizing agent. So your answer is that 3NO3 is the oxidizing agent. So the HNO3 is the oxidizing agent. That's option C. But now let me quickly now look at it if you want to think about it in different ways. Now look at nitrogen here. This oxygen is minus 2, 3 times minus 2, that's minus 6. Hydrogen is plus 1, minus 6 plus 1, that is plus 5. So the answer here is plus 5. Nitrogen is plus 5. I can calculate it. I'm just doing it offhand. Here, nitrogen is plus 4. Is that reduction? Yes. Nitrogen here is what? Plus 2. So it goes from plus 5 to plus 4 to plus 2. That's reduction. So that means that this guy is an oxidizing agent. That's another confirmation. So number 11, which of the following is not a redox reaction? Anytime you see that one element, this is just a code, a gist for you, so that you don't waste time on this. But I'll show you how you can know your answer when you have time, so you can go through it so that you don't make mistake. But whenever it's that one element is staying on its own in the reaction, look at option A, iodine alone. That's a redox. Look at this one, zinc alone. That's a redox. That's option B. Option C, nothing alone. Does not mean you should assume that this is not redox. So, but for now, since there's nothing alone here, this is most likely going to be your answer. Then option D, oxygen alone. So it's a redox. Sodium chlorine alone is a redox. So my answer is option C. She get. Why do you now tell that it is not a redox reaction? You will check the oxidation state. If there is a change in oxidation state, that is automatically redox. So this one going from plus 5 to plus 2 now. That means that's redox already. So I can move on to the next thing. This one is going from minus 1, that's iodine, to 0. The oxidation state has changed from the reactant to the product. So that's a redox reaction. This one is going from 0 to plus 2 for zinc in option B. That means that that's also what? A redox. This one is going from calcium is plus 2 here, calcium is plus 2 here, hydrogen is plus 1 here, hydrogen is plus 1 here, carbon here is plus 4, carbon here is plus 4, carbon here is also plus 4. Oxygen is minus 2, oxygen is minus 2, oxygen is minus 2, oxygen is minus 2. So nothing has changed here from the reactant to the product. Nothing has changed in that option. So that means that the answer to this number 11 is actually option C. Do you get that? You can check here too. This one has gone from 0 to minus 2, so that's redox. This one has gone from 0 to minus 1. If something has happened, so that's redox. Number 12. Number 12 should be a question of stoichiometry. What is the number of grams of potassium hydroxide in 250 cm cube of 1 molar sodium hydroxide? So when you want to solve a question like this, let me quickly solve it for you because it's here. So number of mole is equal to mass over molar mass, and they say number of gram, meaning that mass is going to be equal to number of mole times molar mass. Shey you get? So now, but they gave us something. They said the number of grams of potassium hydroxide. So we want to calculate the mass. That's why they say number of grams. The unit of mass is grams. So in 250 cl of 1 molar. So they give us the volume, they give us the concentration. So you can say that number of mole is equal to concentration times volume. Here you can know the molar mass. You just calculate the molar mass of potassium hydroxide. So you now calculate the number of mole, which is concentration times volume over 1000, because that volume is in cm3, and your concentration is given as 1 molar. Volume is given as 250. Then divide by 1000. So when you do this, you are going to get like 1, 2, and 1. So that's like 0.25. Then you now bring it here. Then the molar mass you have gotten, you multiply it, then that should give you your answer for that question. But that's on stoichiometry. If you want us to have deal with everything on stoichiometry, you can let me know. So I'll teach you how to do problems on stoichiometry. So number 13 quickly, because time is going and I need to stop the video at the point. So even from what I've been doing so far, you should be able to. So let's solve it to number 15. Then if there's any question, you two have to pick all these questions. If there's any question you cannot solve, just you can send me a DM on WhatsApp. I will explain it to you, or you leave it in the comment section and I will try to solve it and upload it for you, that particular question, and upload it for you. So that's why please subscribe. We are not only stopping at chemistry, it's because of time now. So I'm trying to help you to cover all the important aspects you must have missed. So help to subscribe so that you keep getting updates on so many things we do. We teach to the university level. So we'll be teaching you all the things you need to know time. So God bless you. So number 13, which of the following process is iron being oxidized? So without wasting much time, iron here goes from 0 to +2. That's oxidation, right? It has increased. Yes. This one goes from +2 to FeSO for years. That's +2 here. If you calculate it, you get +2 here to +2. So nothing has changed. So there's not no twist wrong. This place from FeCl. So here is like +1 to +3 here. If you calculate it, you get +3 here. That's oxidation. So 3 is correct, 1 is correct. Then even this place should have been FeCl2, but it does not matter. Let's shall go on first. This is correct, this is correct. But if it is FeCl2, that means for now it's only, and yes, even if it's FeCl2, it is still correct. That's why we can just move on. So this one is going from +3 to +2, that's reduction. So the answer is 1 and 3. 1 and 3. So our answer is 1 and 3. That's option D. So number 14, a gas that behaves as reducing agent towards chlorine as oxidized over sulfur. The answer is SO2. Remember I told you the last time when I was teaching the class that SO2 can act as both reducing and oxidizing agent. If you can practice even the few ones that I've solved with you, let's say you don't even have time, you have watched all the classes, you have practiced these few ones, I try to practice them over again, try to get used to them, you realize that the question they will give you in the exam, you'll be able to solve it. So 15, in which of the following reaction does hydrogen peroxide act as reducing agent? So we want to look for where hydrogen peroxide is oxidized. So yeah, now I told you in hydrogen peroxide, oxidation state of oxygen is -1 in peroxide, but in every other compound, the oxidation state of oxygen is -2, but now it's -1 here. So yes, sulfur is going from -2 to 0. -2 to 0, that's oxidation, right? That means this one is acting as oxidizing agent here. But if this one is undergoing oxidation, this is the agent that made this one to undergo oxidation. So this one is called the oxidizing agent. So yeah, Or let's look at it. Oxygen here is -1, oxygen here is -2, -1 -2. That means that's reduction. So that means this one is acting as um, oxidizing agent. If it's undergoing reduction, that means it's the oxidizing agent. This one is undergoing oxidation, that means it's the reducing agent. Shall you get? Option B, -1 to -2, -1 to -2. So -1 to minus, that's reduction. So that means it is still acting as oxidizing agent here, not reducing agent. Then C, that means if you note now too, that means SO2 and A2O2 can both act as what? Oxidizing and reducing agents. In this case is now A2O2 is acting as oxidizing agent. Here is also acting as oxidizing agent. So the next one, iodine went from -1 to 0, that's oxidation. Hydrogen went from +1 to +1, it's still the same thing. So yeah, oxygen went from minus, so that means in this case too, it is still acting as what? Oxidizing agent, -1 to -2. Here now, let's look for the peroxide. So it's going from -1, oxygen is -2, oxygen is -2, but oxygen is 0. So it's going from -1 to 0, that's what? Oxidation. -1 to 0, it's increasing. -1 to 0 is increasing oxidation number. So in option D, it is acting as reducing agent. In option A, B, and C is acting as an oxidizing agent. So let's look at this case. It is from -1 to -2. So that's is acting as oxidizing agent here too. So you should be able to answer number 16. So look at number 16. They say which of the following statement is true? Number 16, you should be able to have answered something like that. In the above reaction, ammonia acts as what? Also look at this. You should be able to answer that. We have done something like that too. So if you can't answer it, just say number 17, then I'll help you to solve it. So number 18, what is the formula of sodium gallate? Now, sodium gallate, which shows an oxidation state of +3. So you are just to look for where gallate is +3 in all of the options. So here now, if gallate is +3, let's look at it. Oxygen is -2, 3, and since it's neutral, that means the ions are balanced. Shey you get? The number of positive balances the number of negative. That's what we mean by being neutral. So now look at this. Oxygen is usually -2, like I told you. And I want to know what oxidation number of these guys. You can calculate it, do what we used to do. That would be 2 times 1 plus x plus 3 times -2 shey get equal to 0. You can do that to get for each of them. But without wasting time, you have to also, Yoruba will say, "Bá ṣe ń kọ́ṣẹ́ là ń kọ́ yàrá." That means as you are learning, you also have to learn to be smart, to be faster in what you do. So being fast now, we just look at oxygen is -2, 3 times -2, that's -6. Sodium is +1, 2 times +1, that's +2. -6 plus 2, that means what will balance that? I will need +4. That means gallium here is +4. So because if I say +4 plus 2, that makes +6. And this one is -6. That means that's the only way it can be neutral. And that means option A is wrong. Here now, hydroxide is -1. So if I say there are two of it, so that this will be -2. There are two of sodium, that will be +2. So that means that gallium has no oxidation state here, which is wrong. You cannot have 0 oxidation states there. So option C, sodium here, this is 3 times -1. That's -3 plus 1. -3 plus 1 is -2. So that means this must have been +2 to balance that out. So that is also wrong. So here now, this is 4 times -1. That's -4 plus 1. -4 plus 1. What does that mean? That's going to be -3. So the only thing that can make that one neutral now is if this one is +3. So option D will be very, very correct. Here is -2 plus 1. That's +1. So that means this guy must have been +1. So the option that is correct here is D. Which of the following serves as an oxidizing agent? You should be able to answer that. Which of these represents a redox reaction? I explained that up above around somewhere here. So you should be able to answer that. So these are the options. So look at them. If there's a change in oxidation state, I also told you that when one element is usually on its own, that's a redox reaction. So my answer is option D. Then, how many moles of electrons are transferred in reducing one atom of manganese in the reaction? So how many moles of electron? Look at this. Now MnO2 plus 4 HCl. This one would have been +4. This is +2. Abi, +4 +2. That means to go from +4 to +2, it must have gained 2 electrons. So 2 electrons are involved in this case. That's the answer. Here in the reaction, copper, this, how many electrons are transferred for each mole of copper produced. This is more like, if you must have understand stoichiometry too. But for they say for each mole, and for 1 mole of copper, let me just quickly show you something. For 1 mole of copper, you must have accepted 2 electrons to give Cu. That's for 1 mole. So that means 2 electrons are involved. And you remember in stoichiometry, number of moles is equal to number of electrons over Avogadro's constant. So if they now say that how many electrons are transferred, so I want to know the number of electrons transferred, that would be number of mole times Avogadro's constant, and that's going to be 2 times 6.02 times 10 raised by 23, and that should be like 1.2 or 12 times 10 raised by 23, or 1.2 times 10 raised by 24. So that's my answer. Sorry, is that minus 24 23? Because the option is showing negative. So I think it should be 20 positive, not negative. So then number 23, which of the following act as both reducing? We have seen that before. That's SO2. This one too, 24. Think about it. Think about this. So think about the rest. You can take a pause. I want to show you the rest of the questions. So you can take pause at interval to answer them. Show if you also know it or not. So you can answer these questions. So look at them one after the other. So if there's anyone you don't know, then you can leave the number in the comment section. So when you leave the number in the comment section, I will help you to solve it. So try to practice them. Those are the rest of the questions we have, not to waste much time on all of these things. So practice them, and please, if you're here to subscribe, subscribe. So we are moving on to electrolysis now, and I'll teach everything on electrolysis and we'll solve all the questions. So if you're writing WAEC, NECO, JAMB, A level, any form of exams, these videos will help you. So thank you so much. I'm Dr. Sodium, a graduate of microbiology from Obafemi Awolowo University and a medical student from the University of Ibadan. So I'll see you in the next class.